Good morning, dear students. Today we will start model number second. Already we have finished 4 models. It is a last model number second. It links to the some definitions from the model first. In model first, we have studied frequency, time period. Time frequency means number of cycles per second is called frequency. Time period means time taken to complete one cycle is called time period. Okay. Number of cycles per second is called frequency. In 1 second, how many number of cycles we have repeated is called frequency. Okay. In AC, we have studied instantaneous value. What is instantaneous value? V is equal to Vm sine omega t. Okay. With respect to here, we have to study the analysis of the RLC. R means resistor, inductor and capacitor. Okay. With respect to this one, analysis with phasor diagram, here we have to show the circuit diagram, waveforms and vector diagram. Okay. First we have to study analysis with phasor diagram of circuit resistor R. Okay. See here what we have connecting. Here we have connecting resistor R. We have giving the input supply Vm sin omega theta. The current flowing in the circuit is I amperes. Okay. Concept is clear. What we have to study, when in the circuit it has only resistance value R, we have connecting the input supply Vm sin omega theta. The giving the input supply V, the current flow is I. What happens voltage and current across the resistor, we have to study. That is analysis of current and voltage in the resistor circuit. Okay. In the second waveforms, we have to see both the waveforms in resistor circuit, current and voltage waveforms meet at a same angle or the same point. See here, it is initially 0. Both it is current waveform, it is voltage waveform. Current waveform, I is equal to Im sin omega theta, V is equal to Vm sin omega theta, which is 5 means 180 degree, 25 means if we are considering one cycle. Okay. When in the circuit consists of only resistance, the voltage and current waveforms starts inside flowing the resistor and meet at maximum and minimum value same point. See here, it is maximum, current is also maximum, voltage is also maximum. Here current is minimum, voltage and both are minimum. Okay. In the vector diagram, voltage and current are in the same line, are in phase. Voltage and current both are in phase, means in resistive circuit current and voltage are in phase, means same phase angle. The phase angle is 0 degree. Here what we have to study this one. Consider a simple circuit above resistor R connected across a voltage source V. V means Vm sin omega theta. According to Ohm's law, this circuit we can apply the Ohm's law. What happens? I is equal to V by R. V means what we are giving? We are giving the input supply Vm sin omega theta divided by R. Okay. This one we have to write I is equal to Vm divided by R sin omega theta. Instantaneous value. Instantaneous value means the value at any instant. For example, it is a waveform moving. At any instant means any particular angle. We have to study the value. The instantaneous value of current Im is equal to Vm divided by R and theta is 0. 0, it may be 90 degree, 60 degree, 40 degree. Okay. In purely resistive circuit, the current and voltage are in phase with each other. Okay, already I have told, in resistive circuit current and both are in same phase. Okay, in pure resistive circuit the current and voltage are in phase with each other. Okay, if voltage and current are in same phase means what happens? Power. What is the formula for power? P is equal to V into I. V is input supply, I is current flowing. Then we have to find the power. Power in resistive circuit, the product of voltage and current. P is equal to V into I. We have basic formula, but it is for DC. But here we are using the circuit is AC. AC means then we have to write Vm sin omega theta, Im sin omega theta. See here, omega theta plus something angle means it may be lagging or leading. Here both are in the same phase. Therefore Vm sin omega theta, Im sin omega theta. Then Vm into Im sin square omega theta. Vm Im divided by 2. Sin square omega theta we can write it as 1 minus cos 2 omega theta divided by 2. Therefore we have taking the 2 here. Okay, therefore then we have to multiply these two terms. Then power P is equal to Vm Im divided by 2 minus Vm Im divided by 2 cos 2 omega theta. Okay, this equation we can write it also. It has two components. One is constant power, another one is fluctuating. Constant means this one, because there is no power factor angle voltage and current same. Here something angle cos theta, therefore it is fluctuating. Okay, therefore average power P average is equal to V into I omega theta. In resistive circuit find the power, then we have to use P is equal to V into I, or we can use I square R omega theta. Then R, if it is in RMS value, what is the RMS value? RMS value sine wave is Vm divided by root 2. For full wave, half wave, Vm divided by 2. Here we are considering one full sine wave, therefore Vm divided by root 2, Vm divided by root 2, it is in RMS. Okay, in waveforms we have explaining what happens the power. What we say, power is equal to, what is the power? Power is V into I square R, means power will be double Vm Im divided by 2. Therefore in waveforms, see here, this waveform what we have studied, it is a current waveform, it is voltage waveform. Same here we have to draw. This is voltage waveform, the dotted it is showing, it is current waveform. It will be in negative half cycle, current waveform, voltage waveform, because it is resistive, both are in phase. What happens the power? See here, power means V into I, both we have multiplying. It is also positive, it is also positive. For example, it is 2, it is 2. 2 into 2, we will get 4. Means the power will be increases in the half cycle. See here, in negative half cycle, it is negative, it is negative. For example, it is negative 2 volt, it is negative 2 volt. What happens? Minus 2 into minus 2, again it will becomes positive plus 4. Means we will get the power in resistive circuit in only positive direction. This is the resistive circuit. In your examination, the question asks, analyze or the circuit diagram with explain or resistive circuit. Then you have to draw the circuit diagram, waveform, phasor diagram, then you have to explain, then you have to write what happens in resistive circuit. Power, it is average power. Average power means it is the total positive half cycle, negative half cycle, we have to take average. Okay, this is Vi and power, purely resistive circuit. Okay, next, same here we have to study inductance and capacitance. In place of resistance we have to use inductance, and next in place of resistance, we have to use capacitance. What happens we will to see next.